So hey everyone, these are Q&As for October. This month, Raul Peralta is here. So thanks for joining, Raul. Yeah, what's on your mind these days?
Yeah, I don't know if I can describe you one of the problems that I have and
Mm-hmm.
then just to brainstorm. But let me see if I can share my screen first.
Oh yeah, you should be able to.
Let me see. I will try this. Wait a second. Sure.
Does that work?
Yeah. It was the other one. Can you see my screen?
I can.
Yeah. So right now I'm working for a financial institution.
Mm-hmm.
So it's, for example, what we're trying to do is like determine which is the credit line that we're supposed to
Mm-hmm.
give to customers. And from the point of view, it's just to finding out some kind of function that it's like the one that I'm plotting here,
Okay.
which is like in the x-axis is like the amount of credit that we're going to give you, and in the y-axis is like the how much are you going to spend. So since a credit card, we get revenue according to how much you are using for credit card.
Mm-hmm.
So at the end, we have this kind of function like if we start giving you, you will spend more and more and more. At some point, you will get to the top of your maximum.
Yeah.
And yeah, so you have a function like this. So at the end, and I have ideas of how to approach this, but it's like we want to find which is the right amount. So we want to give you just the enough credit line, so we don't have like if you don't pay us back, we don't lose too much money because
Mm-hmm.
fraudsters will usually like empty all the credit line and at the end just leave without paying. So just give you enough money so you can have your right amount. And I mean, I think it's like uh, we have this is a model that it's already working, but I wanted to tackle this just using simple Bayesian statistics.
Mm-hmm.
And the idea here is like, for example, for if I see your spend in a given month, given a credit line, is like I can see some dots here, or for us different months, like I don't know, like I can see something here. Then if we decide to give you more money, it's like a higher credit line, and maybe it will be around here or something like that. So you will have like these noisy observations, and this noise, it might be due to maybe it's during the period of time, like maybe December, November, where you spend more because you have like this almost Christmas period or end of the year.
Yeah.
So we might be able to infer these parameters. I mean, for example, I'm going to move here. So we can put, I don't know, like just trying to figure out, we can put some priors on the parameters that define this function, like this one, which is k, which is the max spend, and lambda, which is like the how fast are the things that are converging to that function.
Mm-hmm.
And the blue one is like the real line for a given customer. And the green one is like some kind of prior, well, different curves that might be for any customer.
Yeah.
So yes, once we start finding out more about you, we will have a posterior. But one of the things that I don't know, I'm not sure. It's like I want to make this fast. I don't want to to have like too many, like have to spend like too many points, because this is like a given point is like months. Sorry, a given point is a month. It's how much you spend in this month, because you
Okay.
have to pay in a given month. It's like
Yeah.
how can I determine this function like really quickly? And I was thinking like it's like some kind of sequential decision problem where you have to know. I mean, you have to determine which is like the best point to try next, in order to find out what it's like the shape of this curve. And also there is constraints. It's like once we give you a credit limit, the next should be an increase. Sometimes it's hard because of we're trying to give the best experience. We won't take you. We always can give you increases. So we have to start with something that is basic and then start to give you. But it is hard to go back. So it has to be like incremental, the way we're giving you. So it has to be like some kind of trade-off between, because ideally I will give you like this point here, and I will see this, and then I will have a better curve fitting because I will explore more. But that might be risky because if that customer is a fraudster, it will be a lot that we're going to lose. So we have to be like really small steps here in order to find out this. And this is one part. And at this point, I think I can start using. And for example, here in this stage, we can just use these data points and try to fix these curves and start incrementing according to our predictions according to your next expense. And once we reach like diminishing returns, it's like we will stop there, and that's okay. But as I mentioned, I wanted to do it like fast. And how can I inform these parameters like at the very beginning? And there might be some features that I might use for in order to have a higher convergence. Like for example, if I know the income of the client, that might be correlated with the spend that they will have. And it's like, but I don't know at this point, like how can I integrate that kind of information? Like for example, every time a customer starts, like have a different prior. And I was thinking something like doing something hierarchical. If you have something like if I kind of define a function, I don't know, like the max spend, it is some kind of function according to some features of the customer. I don't know, it could be something linear, no, like have like this, and then this be the setup for something. But I don't know how to. I have that like how to think about this, because here I have like just a regular prior. It's like, for example, just positive value log normal for both k and lambda. But I can replace this just to be something that depends on other features that can inform this. But and we have like millions of users, so I also would like to be this fast and nice. So that's like I have several questions like related to it. Some it's like thinking about like the sequential decision problem. It's like how can I learn the most of this incremental step? The other one is how can I parameterize these things better in order to use additional information of the user, just to have like I don't know, like better priors for these curves. Like how can I how can I inform these priors here? And the other one is related to this is a simple model in the sense that I'm modeling like I don't know how to say, like the average value of each month. But at the end, maybe it will be a better idea, or it will be harder just to model different time series for the client. Like, for example, assuming this is like time, and this is also spend. I have a customer that have something like this, but at some point we decided to give more money. So it will remain like this if we are not giving them money, but it will increase. So these have these counterfactual lines, like like doing some kind of causal forecasting. So I don't know, just trying to come up with ideas. I mean, the simple model here, I think it will be very basic and it's easy to implement. It's a simple model for each of the customers. So I just need to write a program and just do it for everything, and that would be fine. But I don't know. I would like to be like fast convergence to rely less on data.
Thanks for the detailed overview. First, welcome Avram. Thanks for joining. And yeah, we'll get your question just in a bit. But first, to answer, try and give you some pointers, Raul. Yeah, I think from what you're telling me, you should. So, do you have already a model on that, or is it
No,
like
just
you're at that point you're just fishing for ideas?
yeah. I'm going for fishing for ideas. Yeah, exactly.
Okay. So my recommendation would be don't overthink it right now. Like your first ideas, put them in a model already, because otherwise you're gonna get to very complex ideas, and you're gonna try to build the most complex model at the start. So, I mean, from what you're telling me, I think you're in the right direction, and definitely the idea of a hierarchical model makes sense here because modeling just users by themselves, that can lead a lot to overfitting, especially if you don't have a lot of data per user. But if you have a lot of users, and also if you have characteristics of users, so anything about them, I don't know, their age, any social demographic information that you can use in the model, for sure, that's going to be useful, especially since then afterwards you can use a hierarchical model to pull that information. But first, I would recommend starting with a somewhat simple model that's completely unpooled. So one model per user, but still use all the users you have. And then try to add relevant information about those users. So any social demographics information you have. If you have information about probability of default, that will definitely be interesting to add as a regressor. Let's say you're doing a linear regression. I'm pretty sure these will have predictive power to add to the model. So something like, modeling the probability of default of someone. You can already do that with a Bayesian logistic regression, and then you could plug these results. You could write a big model like that, which first estimates the probability of default of a user, and then plug that probability of result as something that's going to help you predict what kind of credit line you could give to each customer. So, yeah, I would start with something like that, somewhat simple. And then to finish, another pointer would be, you're talking about quasi-experiments and structural causal modeling. That definitely makes sense here because, I mean, also prediction, just pure prediction would make sense, right? If you understand that something is correlated and that helps you make better prediction about credit line, well, in the end, it seems like that's what you care about, right? You're not here to change the behavior of users in a way, right? You're not here to cause a better credit line for people. You just want to predict what the best credit line is. So causal structure would make sense, but I don't think it would be like you need to do that. But if you want to look at causal structure and quasi experiments, for sure, yes, start thinking about it from the get go. So with your DAG, directed acyclic graph, and then also afterwards maybe looking at causal pi, the package we've come up with on the Pine Synapse side. And yeah, like all these elements. And once you have something like that, if you still, I mean, you will still have questions. So then you can reach out again to me, and we can basically take it from there.
Yeah, I have a question with the first part. I'm totally in with just applying this kind of simple model to every customer. The thing is, like, if I put it in production, it's like this seems like nice here for customers that follow this kind of pattern of this curve. But I'm afraid, like, there might be customers that for higher values, I don't know, they stay here, but they start going down, and this might be due to external factors, like maybe we were like a bad company and we make something bad for them, or our competitors were better, or maybe they have some economic issues. And what I want it to detect is, like, when I try to fit this model to this opposite line, And the idea is just like if I fit like a Markov chain Monte Carlo, good indicators that I have this kind of data that it's not so good. I have to check like what will be like a good indicator that maybe this model won't be a good idea for this kind of user, or because of the data. So should I check like divergence? I know that I should check like divergences and
Yes, always.
all the the kind of stuff, but I don't know if it's just too good. If they show some kind of error, just like check if they have any divergences or maybe some kind of effective sample that is like really low.
Sure. Yeah, I mean, um, write a first model. Otherwise, you're gonna end up overthinking it, and it's not gonna be the good solution. Don't try to, outsmart the model already when you don't have it. Write the first model, see the kind of difficulties you can have, because if you try to anticipate all the kind of difficulties you can have, first, yeah, you're gonna be right sometimes, but there's a lot of them you cannot foresee. So you're gonna lose time in the end if you just try to outguess uh, the sampler. So my advice would be start the first model and then take it from there. Okay.
Okay.
Awesome. Yeah, and now I'd like to give the floor to Avram. But yeah, thanks a lot, Raul, for reaching out. Definitely try that. And I think you already booked a slot with me on TopMate for next Friday. So definitely next Friday, we'll keep digging into that.
Okay.
Yeah, I'm just here basically to give a little bit of appreciation. I looked a little bit at your involvement with the PyMC marketing library this week and was very impressed. And sort of like buy till you die models and things like that. And this gamma gamma, I don't know if you're immediately familiar. I'll just post the link here. And I was just very appreciative to see that kind of work already done and documented. I guess my I don't have that much familiarity with PyMC in particular. I've been mostly doing BRMS kind of things, and particularly the iData object. I guess suppose you have several models, like in this example, from the margin, there's the the CLV quick start, and then VGNBD model, and then gamma gamma model. Suppose you have just the examples that are there. How would you compare them? Would you use a Loo approach, or what would your advice be there, just in generality?
Yeah, great question. Oh yeah, first something, Raul, before I forget, I put for you in the chat the case study that you wanna check out if you're interested in causal analysis that we did on PyMC Labs. That's gonna give you a good overview, and then also the link to causal pi for quasi experiments.
Awesome. Thanks.
And Avram, yeah, thanks so for the link. So gamma gamma model, but then also just in general, it seems like your question is when I have several models, what do I do to decide between them? And I think it's a really good question because it's not an easy answer, because the literature evolves really rapidly on that front, because it's still quite an open question. What I would recommend is model comparison is not only leave one out cross validation or any algorithm stuff. So on the frequency side, they tend to be very focused on that, try and automate basically the choice of models, which is not really what we tend to do in the Bayesian framework. And I would say model comparison is really much broader than just looking at some result of an algorithm. But it's part of it. So it's kind of like diagnosing a model, right? When you diagnose a model, you're not only looking for one magic number, right? You look if you have divergences, you look if your effective sample size are good, if the R hats are good, if the autocorrelation is low, if the sampling time is high, things like that. So it's basically trying to look for red flags amongst a diversity of diagnostics and tools. So here for model comparison, I would say it's the same. And one of the most important will be doing predictions with your models, because basically you're interested in some phenomenon, right? So do posterior predictive predictions to see what is the posterior distribution of each new data point that your model is predicting, and see if already the models here have some differences. That's going to be one of the main thing, right? Because in the end, the most interesting model is going to be the one that's the most accurate. Also, what is the data generative story that each model is telling? If from your domain knowledge, that model is making more sense from a scientific standpoint than another model that maybe doesn't have one of the variable you are interested in as a predictor, but these variables really important in the causal, not even in the causal, but in the graph of how the different variables are related to each other. So that's another thing. And then, doing some cross validation for sure can be very useful, but that's not the only thing you're going to look at.
Yeah, that really resonates with me. I mean, ultimately, what I do is exactly what you say. I just look at my Y hats, regardless of the methodology, even if it's a machine learning model versus a Bayesian model. I say, well, which one is the best at whatever my gold standard is for prediction? And but I'm just curious because I know there's a lot of work happening, with respect to different ways to vet a model and different information criteria in some cases and Lou, and then you're battling against time-space complexity and how much time do I have to check all the different possibilities. So
I mean, for now, when you're going to use information criteria, so Lou, Wyke, etc., we have that in RVs. So if you do that with a PIMC model or a Bambi model, since you use BRMS a lot, you might want to look at Bambi. Which is basically,
it's very nice.
So it's really good. So basically, once you have that, if you want to compare Bambi models, use the plot compare function of RVs and then do it like that. But again, like always with a grain of salt, especially so right now, the state of the art algorithm is LU-CV. cis-LU CV actually. So Pareto smooth importance sampling, leave one out cross validation. Quite a mouthful. And the result of plot compare in RVs will basically be that. The way to interpret those plots, the best resource on that, I would say, is the model comparison chapter in McElrath Statistical Rethinking. I do go through it from a very practical standpoint in our new online course that we're going to release around November with Tommy Capreto, who is the main core dev of Bambi. So we're finishing up a course about advanced regression in Bambi and PIMC, basically. So lots of flavors of different generalized regressions. And I do go through that a bit in the course, but it's not available for now.
It sounds like there's no substitute for analysis, basically, is that you have to investigate everything.
Yeah. And there is a lot of cases where Lou will not really apply because Lou is making some normality assumptions. And so if you have very, very influential observations, which definitely happens almost all the time with count data or very dispersed data, then Lou can break up. It can break up because your model is bad. So that's going to be interesting. But it can also break up just because the normality assumption break up and everything is okay with your model. So that's where really taking it with a grain of salt and diving into it will be very interesting. Something to play us out, actually, there is a really good case study on the Bambi website. I'm going to link to it right now. Where that one is really good. So it's how to do logistic regression with Bambi. But if you go to the end of the case study, they go through how you would use, because the Lou, they do Lou comparison, cis-Lou comparison, and that doesn't work. You have the warnings that you're going to have a lot, and then they show you.
I've encountered that a lot, both on the BRMS side and
exactly.
You want to do Lou and you can't do it because of 1,000 ways to die, basically.
Yeah,
And
yeah, exactly.
yeah.
And then at the end of the notebook, they go through what you could do to check if that's a problem that's coming from your model, or if it's just a problem that's because, well, your model and data don't fit into the Loo assumptions. So here is the link to
All
it.
right, but just another quick question on a different topic. I know you mentioned once that you had written, or somebody you had worked with had written something in PyMC that says, okay, this is my data, this is what my parameters should be for priors. Do you remember what that was and what the name of it was? I think it was something about, normally you have to you pick a distribution, you think it fits, and then you have to sort of guess at parameterization. But I think you had written something that does the reverse, but I don't remember what it was called.
Okay, I think you're talking about the find constraint prior functions that yeah, it was one of the folks working on that function. So the idea is you wanna use a gamma distribution, for instance, for a parameter that has to be positive. And the gamma distribution is really cool, but because it's very versatile and flexible, and it can take a lot of shapes. But that means it's very hard to parameterize, because it's like it can take a lot of shapes. So what we wrote is that function in PyMC that's called find constraint prior. I'm gonna paste the link now in the chat, where the idea is, well, I know my parameter has to be, let's say it's the length scale, for instance, of a kernel, of a covariance kernel of a Gaussian process. I use that all the time for that kind of parameters. And the length scale of a Gaussian process is basically the idea of what's the duration, for instance, if you're using a Gaussian process for time series, what's the duration through which the covariance between the data points is informative, right? So if you're, for instance, modeling elections, for what's the window of time that a priori I think polls are informative about each other, right? So a poll from 2 weeks ago, is that still informative about a poll from today? Yeah, exactly. So length scale is basically that on a Gaussian process. It's hard to infer most of the time. And so here, the way I usually set my priors is using find constraint prior, and I tell it, well, give me a gamma distribution whose 95% of the mass is going to be between, let's say here in that example, 1 day and 15 days, where I think basically that's my length scale is going to be between 1 and 15. So yeah, just but I don't know the parameters that would give me that kind of gamma distribution. So I just tell PyMC, give me a gamma distribution with 95% of the mass between 1 and 15, and that's all. And then I can use that in my model.
Yeah, thank you so much.
Is that what you had in mind?
Yes, absolutely, yeah.
Okay, awesome. So yeah, I'm going to paste that right now, the link to that function in the chat. And I'm going to have to go because I have another call in 5 minutes that I have to prepare for.
Yeah.
But yeah, basically, that's going to be that. I think that's what you had in mind.
I probably have several smaller questions, but I respect, there's not much time, so it's fine.
Yeah, I mean, office hours every month at the same time. So next month you can come, and also I
guess really quickly just sketch them out. You don't have to answer them. This is Causal Pi aware of the do-y package, and is there synergy between them, or are they two different things?
No, I don't think it is. I think it's two different things, but you have the do operator now in PyMC.
Yes, that's awesome. Yeah.
So I would
and then probably another question to think about but not answer is there? Do you see in the future of PyMC some kind of convergence toward a backend on PyTorch?
No, I don't. I mean, that's not in the works for now, because we've changed the backend a lot, and we're really happy with our current backend, which is PyTensor, which helps us do the kind of things we're doing, especially with the do operator. So do and observe operator, they are really, really cool, really useful. You can see that in the a case study for causal analysis that I pasted for Raul. That's on the PyMC Labs website. We demonstrate that here. Also, I'm going to do, hopefully in October, if not in November, I'm going to do modeling webinar for Learn-Based Stats, where I'm writing it these days, but I just have so many things to do at the same time these days. But I'm working on a case study like that for an LBS modeling webinar, where I'll go through overparameterization, where that comes from, how zero-sum normal can solve that, and also how to use the do and observe operator, for instance, in those cases. So kind of a workflow of how you would use do and observe. So I definitely recommend, if you're interested in that, to sign up when I announce it. And yeah, I pasted the find constraint prior right now in the chat, so feel free to check that out. And of course, any question, so come next month to the office hours if you want. Otherwise, there is my top mate page that that you can book some time from time to time. I'm gonna paste the link here in the chat. And what else? Yeah, and of course, any question on the Slack, for sure. So here is the top mate page. Here's the top mate page. And yeah, Slack, top mate, and next office hours. Okay.
Excellent. Thank you.
Awesome,
Thank you.
guys. Yeah, thanks a lot for joining. That was super interesting. That was super fun.
Yeah.
So
Bye.
thanks a lot. Take care, and well, Raul, see you next week. And Avram, hope all is well in LA, and see you very soon.
Thank you. Ciao.
See you guys.